G'day everybody, my name is Reese and this is my video series where I explore how to do cool things in SPSS in less than 10 minutes. In today's video we'll be exploring how to perform a two-way factorial ANOVA in the scenario where the interaction is significant. Before we jump straight into SPSS, let's just quickly revise what two-way ANOVA actually does. So two-way ANOVA allows us to explore the effect of two independent variables simultaneously. So it allows us to look at the main effect of one IV on the DV, the main effect of the other IV on the DV, but also how the two independent variables interact together to form an effect on the dependent variable. In this video, I have made up data where IV1 is training method, IV2 is gender, and we'll be looking at how these two independent variables impact confidence starting a new job. Okay, so we've moved our way to SPSS now. Before I start the analysis, let's just quickly reorientate ourselves with this data set. So I have gender as my first IV, training program as my second, job confidence as my dependent variable. If I move to the variable view, you'll see that gender's been coded 1 as male, 2 as female, and for training program we have no training, one-on-one or group-based training. Now before I perform the ANOVA, so before I actually look at some statistics, I'm going to perform a graph first, just to show you the general trends that we're going to observe statistically later on. So I'm going to perform a line plot or a line graph here. I'm going to separate them by groups. Now I want to look at what is the effect of training program on job confidence and how this differs according to whether the employees are male or female. Going to go ahead now and hit OK to generate my plot, and what we see here is the effect of training program on the job confidence levels being different for males and females. You see here the blue line, this represents the male employees. It looks like job confidence was at its lowest for the no training condition. It goes up a little bit for one-on-one, and then it goes up again for group-based training. For females, however, the green line, their confidence levels, they started at the lowest too at no training. They went up a little bit for one-on-one trainings. That seems to be consistent for the males. But can you see here how it drops for group-based training? So it seems here that the effect of training program on job confidence differs according to whether the participants were male or female. In particular, this area here of the graph, job confidence went down here for group-based training in the females, however went up here for the males. So this visually demonstrates why we have an interaction here between our variables. Again, the effect of training program on the mean job confidence levels were different according to whether the employees were male or female. After viewing our relationships visually in an interaction plot, we're now ready to explore our data statistically. So I'm going to go ahead now and click on Analyze General Linear Model, Univariate. This is where we're going to perform our factorial ANOVA. I'm going to drag my dependent variable job confidence across and my independent variables gender and training program across as well. Now there are other options that I could select here. I'm going to keep things nice and light though for the purposes of this video. If this was your data, you would of course be running all of your assumption checks as well. I'm going to be assuming for the rest of this analysis that those assumption tests have been performed and have been met. I will select just a couple of extra things, so I might just go for descriptive statistics and estimates of effect size. We will be coming back to this dialog box in a couple of minutes. I will be playing around with this interaction effect here. However, I'm just going to run the initial factorial ANOVA first, just kind of replicating or simulating what it would be like if I was running this analysis and I didn't know there was going to be a significant interaction. So we will come back here, but for the time being, I'm just going to keep all the options nice and simple. So I'm going to go ahead now and click Continue and then OK to generate our output. Okay, so I've just scrolled up here just to show you this is our original interaction plot. Now if I scroll down, here is my univariate analysis of variance. The first two tables are just our descriptive statistics, so they would be useful for reporting purposes. But the real table that we're wanting to interpret is this tests of between subjects effects. So in this table, we get a special row for each of our main effects So one belongs to each independent variable, and then more importantly, we have this row here dedicated to the interaction effect. Now, the most important statistic to interpret here is this significance value, the p-value, and as you can see for this interaction effect here, this is less than 0.05, so we can deem this as being statistically significant. In a similar sense, our main effect for training program is also significant, but the interaction would always take priority over any main effect which happens to be significant. The reason being is that the interaction effect is actually demonstrating that the effective training program on job confidence somehow differs or changes according to gender. So the relationship is much more complicated than simply looking at training program on job confidence alone. We have to introduce this effect of gender as well. So whilst it would be important to report the results of the main effects, it's this interaction effect which is going to dictate our next stage or next step in the analysis. So that next step is essentially what impact does training program have on job confidence for the male employees and the female employees separately. So what we want to do here, we want to perform another analysis that separates males and females out so we can isolate the effective training program on job confidence for each of the genders separately. Now, this next stage in the analysis where we isolate the effective training program on job confidence for males and females separately, that's called a simple effects analysis or a simple main effect analysis. Same thing there. Now, there are two different ways that you can do this in SPSS. The first way I do not recommend. It's the easier method, but it's not as sophisticated. So if you wanted to, you could go to Data, Split File, split the file by gender, and then run basic one-way ANOVAs of training program on job confidence. That would then be performed twice, once for the males, once for the females, and you could isolate the simple effects that way. The reason that I don't recommend that you do that is because each of these one-way ANOVAs would be performed separately for males and females with different error terms. So you would actually get a different pooled measure of background variance for each one of those separate ANOVAs, so it's not the ideal approach. The much more sophisticated approach, and the approach that I'm going to now adopt, you will need to use syntax, however. So SPSS does not offer an option to do this method by default in the options. So there's no actual options to do what we're about to do, but it's very easy with just a simple modification to the syntax or the code that SPSS is running behind the scenes. So I'll just go back to my output view for a moment. I'll click on that again. So I'm going to go ahead now and click on Analyze General Linear Model Univariate. Everything is there just like it was before, but now what I'm going to do is I'm going to click on Options here. I'm going to drag my interaction effect here to this little box here called Display Means For. Now what this is going to do, it's going to prime my syntax to make it even easier to edit. Now I will make one small change to an option here, because I'm going to be looking at the simple effective training program on job confidence separately for males and females. That's going to technically be two separate simple main effects. So I'm actually going to adjust my alpha level here, which is going to change my confidence intervals for my pairwise comparisons. And we'll discuss that more in a little bit. The reason that I've put it down to 0.025 is because there's going to be two simple effects. One for the simple effective training program on job confidence for males, and then another one for females. By lowering my alpha rate here, I'm going to be maintaining an overall alpha rate for the whole analysis of 0.05. I'm going to go ahead now and click on Continue. And now rather than clicking on OK, we're going to select Paste. And I'll just drag this into view. This is our syntax window here. So if I was to highlight this here, it would simply run that analysis, all those options that I've just clicked on. But I want to isolate this particular row in the syntax here, estimated marginal means. I'm going to type a word in here. Nice simple word, it's just compare. And now I'm going to open bracket. And what I need to type in here is the name of the variable that I'm most interested in. Now, I'm most interested in the effective training program on job confidence for the two genders separately. So I've popped training program in compare there in the brackets of the compare function. So what I can go ahead and do now is highlight this syntax with that modified version, hit the green arrow button, and rerun my analysis. Now, a lot of this output will be identical. So my descriptive statistics are the same, my tests of between subjects are the same, but now what I have this new bit of output here called estimated marginal means. So I get my pairwise comparisons here. So if I wanted to isolate some of the individual groups to see if they're significant or not, I would use this table. But what I should probably do before looking at pairwise comparisons is assess the simple effects initially first. So what I want to really know is, what is the effect, or is there even effect, of training program on job confidence for the males? And then secondly, what is the effect, or is there one at all, of training program on job confidence for the females? And we actually get that from this bottom table here called univariate tests. So what these are separate one-way ANOVAs that SPSS has performed for us. But note here that the error term has been kept constant. So 14.107, 14.107, 14.107. So it has maintained the same measure of background variance for all of the main effects and interaction, and the simple effects as well. That's very different from had we have gone to data, split file, and then split by gender, and then ran separate effects for training program on job confidence for males and females separately. So whilst it's a little bit trickier having to use syntax, I can assure you all this is the preferred method. So what we can see here, so this is this row titled here male and female, this is the separate effect of training program on job confidence for the two genders separately. So for males here, we can see the p-value is less than 0.05. So the effect of training program seems to be significant for males. And similarly for females, it also appears to be significant. So both of the simple effects are significant here. However, for the interaction effect to be significant, somehow these simple effects between the genders, they must differ somehow. There must be something that makes them unique. So we can kind of see that from the eta squared figures here. It appears that the effect size of training program on job confidence is slightly higher for males in comparison to the females. But if you remember back to our initial interaction plot, we also saw that the pattern of means was different as well. And that's the final stage of our analysis, to deconstruct what those means are actually doing. So if you had a planned hypothesis, so if you had some a priori hypotheses formed, you could actually follow up these simple effects with planned contrasts. So you could actually set up your contrast weights if you wanted to. However, I don't have any a priori hypotheses here. I'm running this analysis purely for exploratory purposes. So instead, I'm going to go back up to this table that we looked at very quickly before, and deconstruct what these pairwise means are doing. So here we can see for the gender male, no training versus one-on-one, this difference was not statistically significant. Whereas no training versus group-based training, that in fact was. So we have no training versus one-on-one, no training versus group-based training, and then one-on-one versus group training. That's our final comparison. That was significant as well. So hopefully that you can see that we're able to observe that the simple effect overall for job confidence, for training program on job confidence for males was significant. And then via the pairwise comparisons, we can deconstruct that a little bit more. In a similar fashion, we can do this for females as well. So we saw that females were significant, and then in the pairwise comparisons box here, we can break apart what the pairwise means are doing. So there was a significant difference between no training and one-on-one. That's a little bit different to the males also. No training versus group-based training. And then similarly, one-on-one training versus group-based training. So we can do that final step in our analysis, know what the individual means are doing. And that's essentially it for a factorial ANOVA with an interaction. That added tier of complexity when the interaction is significant leads us down the path of performing a simple main effect or a simple effect analysis, isolating the effect of one IV on the DV for each level of the other independent variable separately. You then assess the significance of each of those simple effects, and then you follow up any significant simple effects with pairwise comparisons or planned contrasts depending on what your hypotheses were for your given research scenario. There is one small little caveat that I'd like to add here. If your simple effects only had 2 levels, so I have 3 levels of training program here. If my simple effects hypothetically only had 2 levels, your analysis would essentially stop at the simple effect stage. If you found a significant result, you could simply look at your means or your means here, and then you could infer what direction that simple effect was actually going in, which group happened to be smaller or larger or greater or whatever words you want to use to describe that effect. The pairwise comparisons table is not particularly useful if your simple effects, if your variables here only have 2 levels, because you'd only have one comparison to look at anyway. And that essentially wraps it up, guys. So just for a quick summary, whenever you're performing a factorial ANOVA, I suggest you always observe your relationship via an interaction plot first. You run your base ANOVA to see if your interaction is significant. Once you do find a significant interaction, you rerun your analysis with simple effects turned on. So you'll have to use the syntax for that. You scroll all the way down the bottom of your output to this little table called Univariate Tests. You'll see that you can assess the effect of both of your simple effects separately. You then follow up any simple effect which happens to be significant with an appropriate pairwise comparison or planned contrast. Okay guys, that wraps up this short video exploring factorial ANOVA designs where the interaction is significant. I hope to catch you next time for another one of my videos where we explore more cool things in SPSS in less than 10 minutes.